Alright students, so let's continue with Sp2 hybridization. So I choose boron trifluoride for example of Sp2 hybridization. This is the Lewis structure of boron trifluoride, and from the Lewis structure you can see there are 3 bonding pairs. 3 bonding pairs equivalent to 3 electron groups. Okay, so number of electron groups around boron, there are 3 electron groups. Okay, since there are 3 electron groups, therefore boron undergoes Sp2 hybridization, and according to Vesper theory, the molecular shape, okay, the molecular shape of boron trifluoride is trigonal planar with bond angle 120 degree. Okay, so before you start to explaining or describe the hybridization process by using valence electron orbital diagram, write down the electronic configuration of boron. Okay, so the proton number of boron is 5. 1s2, 2s2, 2p1. Alright, and the the proton number of fluorine is 9. The electronic configuration is 1s2, 2s2, 2p5. Okay, so now draw the valence electron orbital diagram of boron, because boron undergoes hybridization. So we have to focus to the valence electron of boron. Boron has 3 valence electrons which occupy 2s and 2p orbital. So ground state, (2s2), okay, because there are 2 electrons occupy 2s orbital, and 2p has 3 2p subshell has 3 orbitals, 2px, 2py, 2pz. So we have to draw 3 2p subshell of 2p, right? Okay, and only 1 electron occupy 2p orbital, yang mana it could be px, py, pz. Okay, so now how many sigma bonds around boron? There are 3 sigma bonds around boron. In order to form 3 sigma bonds, boron need 3 unpaired electrons, and from the valence electron orbital diagram, it shows that only 1 unpaired electron is present. So now in order to get 3 unpaired electron, 1 electron from 2s orbital of boron is promoted to 2p orbital of boron. So now we have the next step, promotion of electron. 1 electron from 2s orbital is promoted to 2p orbital. So now we have 3 unpaired electrons. So before the covalent bond is formed, boron must undergo Sp2 hybridization. So the next step is the hybridization process. So Sp2 hybridization. So what happened? 1 2s orbital mixed with 2 2p orbitals of boron. So we get a new set of hybrid orbital which is called Sp2. 3 Sp2 hybrid orbitals form. Okay, 1, 2, 3. And in each Sp2 hybrid orbitals, there is one unpaired electron. So, one orbital of 2p, empty orbital of 2p is left. So, kita lukis kat sini 2p empty orbital. Okay. So now we are going to show the orbital overlapping. In order to show the orbital overlapping, we have to refer to the valence electron of fluorine, because the sigma bond is formed between boron and fluorine, and valence electron of fluorine will involve in the formation of the sigma bond. Okay, so kalau kita lihat kat sini, macam tadi saya dah tunjuk, 2s. Okay, kalau saya lukis orbital diagram bagi valence electron of fluorine, kita ada 2s2, 2p5, 1, 2, 3, 4, 5. Jadi, in order to form the sigma bond, boron will contribute unpaired one electron from one of its sp2 hybrid orbitals to overlap with 2p orbitals of fluorine. Jadi kalau kita tengok pada valence orbital orbital bagi valence electron of fluorine, okay, 2s dengan 2p, hanya ada satu sahaja 2p orbital, salah satu 2p orbital dia yang masih lagi ada unpaired electron. So maksudnya yang inilah yang akan dikongsikan dengan salah satu elektron daripada sp2 hybrid orbital of boron. Okay, jadi maksudnya overlapping antara apa? Each sigma bond is formed when one sp2 hybrid orbital of boron overlap with one of 2p orbitals of fluorine. Okay, sekarang masanya kita nak tunjuk overlapping. So kita lukis dulu hybrid orbitals of boron. Since boron undergoes sp2 hybridization, so sp2 hybridization, the electron group arrangement is trigonal planar. Okay, the molecular shape is determined from the Vesper. Tapi saya bercakap tentang electron group arrangement kalau there are 3 electron groups. So sp2, the electron group arrangement is trigonal planar. Right? So macam mana bentuk sp2 hybrid orbitals? Dia bentuk macam trigonal planar. There are 3 sp2 hybrid orbitals. Okay, kita lukis. 1, 2, 3. So this is the hybrid orbitals of boron. Namanya apa? sp2, sp2, sp2. So this is boron hybrid orbitals. Alright, so in each sp2 hybrid orbitals of boron, there is one unpaired electron, and this electron will be shared with one valence electron of fluorine. So dikongsikan macam mana? Mesti melibatkan overlapping of orbital. So salah satu sp2 hybrid orbital akan overlap dengan 2p orbital of fluorine yang ada unpaired electron tu. It could be 2px, 2py, 2pz. Boleh jadilah 2pz. Tapi yang penting disebabkan ini adalah sigma bond, maka overlapping mesti secara end to end. Okay, baiklah. Jadi sekarang saya nak tunjukkan overlapping dia. Okay, so 2p bentuk dia mesti dumbbell. Okay, so this is the 2p orbital of fluorine. So bila dia overlap, apa yang berlaku? Sharing of electron. So kat sini ada unpaired electron, and now the sigma bond, one sigma bond is formed. Okay, so baru satu. So ada lagi, katakanlah yang sini pula. fluorine 2p. Okay, overlap, and in the overlap region occupied with electrons, shared electron with opposite spin, and now the second sigma bond is formed. Alright, okay, and next, fluorine 2p overlap region occupied with shared electron with opposite spin, and this is another one sigma bond. Okay, so now you can see the molecular shape determined according to Vesper is trigonal planar with bond angle 120 degree. So dia align ataupun sejajar ataupun tally. Okay kelas, ini contoh untuk Sp2.